So today what we're going to do is we're going to take a look at graphing exponentials. And so as a reminder, we've talked about y equals a times b to the x. So this is our exponential function, where b, it's equal to growth. And we said that's 1 plus our r value. And b is equal to decay when that equals 1 minus our r value. So we're just going to take a look at what does a basic exponential look like. So if I was to graph 2 to the power of x, so 2 to the power of x, and let's just make an xy table with this. So when x is 0, 2 to the 0 equals 1. 1, 2 to the first equals 2. 2 squared is 4. 1, 2, 3, 4. And let's say to the negative 1. So that's 2 to the negative 1. So 1 over 2 to the first is 1/2. And we have this exponential that it has an asymptote. It never goes to the negative side here. And so if we take a look at Desmos here, we can see 2 to the power of x. And we can see the graph here, it's running right along the asymptote. So now if we take a look at, let's take a look, so that would be exponential growth because our b value is 2, it's bigger than 1. So let's say we wanted to graph y equals 1/2 to the x power. So again, we have an xy table. So when x is 0, anything to the 0 power is 1. When x is 1/2 to the first, well, that's just half. Let's say we have 2, so 1/2 squared. We square the top and bottom, so that's 1/4. Well, what if it goes backwards? What if we did -1? Whoops. So we had 1/2 to the -1. Well, we distribute 1 to the -1, 2 to the -1, and then we flip those. So it'd be 2 over 1. So that's 2. So it's our exponential, but it's decaying, and it still has that asymptote. So we're going to talk about some things here. So let's say you had, so we're going to talk about some transformations. So for example, what if we had y equals a times b to the x, and then we had like a plus d? So for example, what if we had 2 to the x plus 3? What do you think that plus 3 does? Well, if you're not sure, let's go to Desmos and say, okay, plus 3. What did that do? Well, it shifted it up and down. So this shifts and it's our asymptote up and down, up or down, because it'll be down if it's minus. And then we could also have what if we had y equals -2 to the x plus 3? Well, what do you guys know those negative does? And again, we could go back here and let's say, okay, so what does a negative do out in front? Well, it reflects it, so it flips it. So this negative, so if we had, I should write that again. So if we had y equals -ab to the x, it flips that graph. And we're going to learn we should just be able to look at some graphs and know the general shape. So for example, to know if we're typing it in the calculator, right? Because we're going to be able to use a calculator to graph these. So for example, let's say we had y equals -3 times 2 to the x. Y equals 2 times 1/3 to the x plus 3. Y equals 3 times half to the x minus 4. And let's say we have y equals 5 to the x minus 8. So what I want you guys to do is we are going to first identify like where the horizontal asymptote is. So has it shifted vertically? So this one, the horizontal asymptote, it hasn't shifted, so it's at y equals 0. Whereas the second one here, our horizontal asymptote, it shifted up, so it's at y equals 3. This third one, where's our horizontal asymptote? Well, it's moved down 4, so it's y equals -4. I don't know why I have double equal signs here. And then this next one, 5 to the x minus 8, it'd be at y equals -8. So HA, again, is our horizontal asymptote. And now what does this look like? So we have a 2 and a negative. So that means it's a growth one. But it also means it flipped. So growth looks like that, but the 3 would flip it down. So the general shape, it would be going down. Whereas if we look at this next one, we have the 1/3, so that's decay, but it's positive, so it hasn't flipped. So it's just a decay graph. This next one, we have a half, and it's positive. Is it the same one? No, slightly different. It's half, so it's decay, so it's going down, and it hasn't flipped. And then this next one, we got 5 to the x, so it's a growth, and it hasn't flipped. So a decay one, let's say we have y equals -2 times half to the x plus 3. So our horizontal asymptote is at y equals 3. I see this decay, so I know it's decay, but we have the negative, so it flips. So it'd really be like that, because it's like it flipped over. So what we're going to do is we're going to take a look at how Delta Math wants you to graph these, okay? So let's take a look at this first one here. So we have, y equals -3 times 2 to the x plus 3 plus 4. So the first thing you have to do is identify the horizontal asymptote. And so that's at y equals 4. So what you do is they're all going to be horizontal. And you see this line at the bottom? You'll see a dashed line. So let's move that up to 4. And then we'll deal with the rest of this. So we have to find a couple points. Well, I personally think when finding points, what makes our exponent equal to 0? Because it's really easy when our exponent is 0. So when x is -3, we'd have -3 times 2 to the -3 plus 3 plus 4. Well, we know anything to the 0 power is 1. So -3 times 2 to the 0 plus 4. So this is really just 1. So it's -3 plus 4, which is 1. So we can graph the coordinate. You can take 1 and graph to -3, 1. And now to find another point. We could start guessing and checking, but a really easy way to do this is to go to Desmos. So we have y equals -3 times 2 to the power of x plus, and do you notice how it goes down there? So we have to do parentheses, x plus 3. Now we can go over plus 4. So there's our graph, which, sorry, you can't see it on here, my bad. So we can see our graph. So it was a growth one and it was flipped, because you can see The 2 makes it growth. So if I go before this, there's our growth, but we added the negative. And you can get a table of values. So hit this little wrench here. And then do you see where it has that table? Hit the table, and you have all sorts of points. So, when we put in -3, so -3, 1. So -2, 2 is another one. So we can go -2, 2. So 2 to the 1/3. We have y equals 2 times 1/3 to the x plus 3. So first of all, let's identify our horizontal asymptote is at 3. So we'll go here, our horizontal, find that dashed line and bring it up to 3. And we know that this is a decay function because of that 1/3. So we know it has to be going down. And again, we can go to Desmos to get some points here, or we can make our table. So 2 times 1 divided by 3 to the power of x plus 3. And then again, hit that little wrench in table. So we need them to fit on the graph. So we have -1, 9. So there's 1 point. And then we have 0, 5. And we have our next. And again, to get that point on our own here, again, we could make an XY table. And what makes a 0 in our exponent? Well, that's just when x is 0. Because if we type that in, 2 times 1/3 to the 0 plus 3, well, anything to the 0 power is 1. So 2 times 1 is 2, plus 3 is 5. And we have our graph.